Yes, sure. Oh, okay. Okay, fine. Okay. You think there is a timer somewhere, or I should use mine?
Just yours, in fact.
Okay, yeah. This laptop.
If you use numbers, it's ready.
Hola. My name is Vincent Stellet. I'm working at ARM in architecture, and it's a pleasure to be here with you at the Linaro Connect in Madrid. It's been 3 years now that SystemReady IR has been introduced, and I think that for this third birthday of the program, it's a nice opportunity to look a bit back at the journey we've been through. So let's have a look at the contents of this presentation. I will go through a brief IR recap. Actually, John has done a very good job already, so maybe I can go very rapidly through the software stack, the standards, and then we'll have a look actually at the timelines of a few key pieces for IR, and we'll look at the certification data as well. And if time permits, we'll highlight some lessons learned along the way. Otherwise, you'll have to download the slides afterwards. I'm sorry. With that, let's start with a brief SystemReady IR recap. So as was said, that's a journey toward the software just work goal SystemReady IR for the embedded Linux ecosystem on ARM. All the SystemReady bands are leveraging UEFI, so IR is no different, but what is specific to IR is the Devicetree, as John told us just before. So, and what can we expect from an IR system? Well, that's what we are testing during certification on the right. So you see in black the characteristics of IR1X, which was largely about booting an OS, a standard off-the-shelf OS on the system. Later on, the ingredients in blue were added by IR 2.0 timeframe, so that's about security and starting the device tree verification journey. And lastly, in green, the ingredients added by IR 2.1 time, which are about quality of the higher level features of the system. Let's look at the software stack very rapidly. So that's a typical IR 2.x capable system we are looking at here. So you see there is the hardware eMMC at the bottom in gray, which is actually providing the anti-replay feature. which allows us to have this secure storage for the UEFI authenticated variables. You see the trusted firmware in yellow, providing support for the ARM secure world, and the operating OS, the OPT in the secure world in green, running StMM as a secure partition. You can see also U-boot, an important component here in that example stack, which is actually implementing the UEFI interface and providing the device tree to the OS as a UEFI system table. Another alternative would be to use EDK2, because SystemReady IR is not about the implementation, so it's just one example, one popular example of the software stack. And with that, let's look at the certifications very briefly. So this is the tree of the SystemReady IR certifications. You can see at the top, the root of that tree is the SRS document defining the SystemReady program. And you see in dark the EBBR specification, which is defining the UEFI subset, which is required for IR. That's a community-driven specification, which means that you are welcome to join and participate if you like. Whoops, sorry. Okay, so we've done a brief IR recap. We can have a look at a few timelines of key pieces for IR, starting with the SRS specification. This is the SRS timeline. So the x-axis is the time, and you see in the middle with the horizontal line we have the SRS document versions 1.11, 1.2 to 2.2. The SRS is really defining all the system-ready bands, not only IR, but on this slide we are showing only the IR-specific aspects to relate with the IR version, EBBR version, SRS version, and ACS version. So the ACS here is the software test image we are using during certification to verify the system. And you see that the SRS timeline is very regular. This is basically a time-driven document, which is not the case of other pieces. So we'll look at the EBBR timeline. So a bit of warning first. The scale is different. This is starting 2 years before the SRS. And you see the version 2.00 corresponds to IR1X, and version 2.1.0 corresponds to IR2X. This is more feature-driven, and that is a fairly mature document now. Also on the right, we are showing the yet-to-come version 2.2.0, which is basically ready but not out yet, but it's due very soon. One interesting feature is the DTB grid, which made it into version 1.01 of the EBBR specification, and which was in fact upstream, you could say, to UEFI 2.9 later on. That's an important feature, as we discussed even during John's presentation. The DTB grid is used to pass the device tree to the OS as a EFI system table. Okay, let's have a look at the U-boot timeline now. Again, mind the time frame. This is starting even 2 years before EBBR, 4 years before SRS. So I don't want to spoil Ilias' session just after this one, because he will give us much more details on the U-boot features and even the most recent developments. So it's suffice to look at the EFI loader, which was introduced in 2016 by Alexander Graf. This is a crazy idea of running EFI binaries from U-boot, and this is what enabled the IR journey basically for U-boot. And you see that on the far right, the first IR-capable version of U-boot is 2021-04, which is happening 5 years after the start of the EFI loader. So the takeaway here is that it takes time to develop and mature that kind of feature. And if we summarize everything, we get the IR timeline basically. So the scale is back to the SRS time frame here. It's a 3 years span now. And you can see that this is the byproduct of all the previous timeline we saw, basically. It means that if we want IR to advance, we need not only the specs, but also the components to be on par with the specs, and everything needs to work together. Okay, so we've looked at the timelines of a few pieces. Let's look at the data that we have gathered when certifying those 40-ish IR systems in the past years. And we can start by looking at the overall certification data. So what you see here, on the left, this is a graph of the number of certifications over time for all the SystemReady bands. And on the right, this is actually the chart summarizing the point on the far right of the graph. This is where we were a few weeks ago when submitting the slides, basically. And you can see that from all the SystemReady bands, the IR certifications are very near 1/3 of the total certifications, in fact, which is not that bad for IoT type of systems. But let's look a bit more into the IR certification details. So here we see the IR certification versions over time, with the graph on the left over time and the chart where we were a few weeks ago on the right. The fair share of the IR certifications are IR 1X certification, more than 90%. And we can see the version 2.0 starting to appear. With the security extension, actually. Also, we have 2.1 certification being tested as we speak, and which should be due very soon. Let's look at another aspect of the IR certification, and this is the IR certification labs. In the beginning, on the left of the graph, you can see that in blue, ARM was doing all the testing and results collection. But at some point, a number of certification labs have been involved. So there are now 3 certification labs which are capable of testing and collecting results for IR certification on different time zones around the globe. And the idea was that ARM ideally would be completely out of the loop for the certification results collection, and that the lab could handle the fair share of testing. Well, it turns out that half of the certification have been done by ARM in the end. Because in fact, ARM is very involved in the first type of certification. The first time an SoC is part of a certified system. The first time IR version X or IR version 2 certified. So ARM is still very involved in those certifications. And let's see now at the U-boot version. So U-boot is not mandatory for SystemReady IR, but de facto it's a fair share of all the certified systems. So not shown here are a couple of Raspberry Pi which were certified with EDK2. But here we are looking only at the certifications which were done with a U-boot-based firmware, and we see the version of that U-boot here. So you recall the first version, which is IR capable, is 2021-04, and that's actually more than a third of all the certification. You'll notice also that the certified systems are lagging a bit compared to the latest release of U-boot, because, for example, 2407 is being prepared as we speak right now. I think we have RC2 or 3, I don't recall. So there is a 1-2 year delay before it reaches the certified system in practice. But we have right now, as we speak, firmware based on 2023 being tested. So that's a bit different now. It's not part of the firmware. This is the OS used during certification. During IR certification, we are installing at least 2 OSs on the system as a mean to verify the functionality of UEFI and Devicetree. No BSD to date.
This has been very much the step-by-step of how do we start to create interoperable. Oh, sorry. If someone comes along and wants to certify with BSD, awesome. Right now, the rules, we started with rules that made sense, and then we'll expand from there.
We also need a BSD vendor or OS vendor to actually actively support this.
Yes.
Well, again, BSD is welcome, but it's not present there, sorry. So what you see are the 4 distros which were recommended in the SRS from the beginning: Fedora, OpenSUSE, Debian, and Ubuntu, which is well represented here. Starting with SRS version 2.2, the last one, we are now recommending, in addition, RHEL, SLS, Rocky Linux, and OpenWRT, so they are starting to show up on the chart from a few weeks ago. But okay, I'd be happy to work on a BSD certification for sure. And I'm trying from time to time on some systems, but it's... Okay, looking at the Linux kernel versions used during certification here. Again, this is not part of the certified system, but it's something that we use to test the system. So we have a Linux in the ACS and in the OSs which are installed during certification. So you can see that, in fact, we have fairly recent kernels showing up on the right, 6.7 being the most recent one, while we have 6.9 just out. So we are not that far in terms of Linux kernel, and this is due to 2 facts, basically. So there is one motivation with the ACS itself, which has a Yocto kernel, so it follows a fairly recent 6.4 type of kernel right now. And we have also the OSs installed, which are sometimes daily builds, which means they are using fairly recent kernel as well. So, yeah. And with that, we can look at some more hardware-oriented aspects of the certifications. This is the type of processors which are found in the certified systems in IR. To make a parallel with the Raspberry Pi, which is a very well-known platform, so maybe it's more easier to figure. You have this Cortex-A7 on the right in red, which is a 32-bit type of processor that corresponds to Raspberry Pi 2. You have in blue the fair share of the represented processors here is A53, one of my personal favorite, by the way, which is in the Raspberry Pi 3. And you have at the bottom in orange Cortex-A72, the only out-of-order core on that chart, which is the Raspberry Pi 4 equivalent. And we'll have a look at the SoC data as well. Here we can see that the IMX item family is really a success story for SystemReady IR. So this is thanks to NXP being a lead partner in that program. And it works really well, the way we work with NXP on that family. So we work with NXP on early certification of their reference design and also BSP, which means that when those designs are certified, NXP customers retrieve that as a starting point in terms of hardware and also in terms of firmware, which means that the systems coming out of those OEMs are much easier to certify after that. And it's really a good model. Okay, we've looked at the certification data. I think we are basically out of time. Or
We're on to break now. It'll probably take a couple minutes.
okay, a couple minutes. So I suppose maybe for the lessons learned, we'll skip. I let you read the lessons learned offline after the connect. And okay, with that, it's thank you for your attention, and a big thanks to all the people who made SystemReady IR possible. I'm thinking about Linaro also, who contributed a lot to the software components and standards, to the partner and the community also defining eBBR. Any question? Okay, otherwise you can catch me during the coffee break.